Hello students, how are you? I hope you are fine. You are staying at home. Today I am going to make video on force and laws of motion. This video is beneficial for those students who are studying in class 9. Okay, I will start my discussion with the definition of force. How can we define this? Force क्या है? Okay, so we know very well when we push or pull any body, then body changes its position or tends to change its position. Okay, so force can be defined as push or pull. When we apply push or pull or force on a body, the body tends to accelerate, body tends to change its shape or size. So we can define force in any way. So force is a physical quantity which is applied on a body to change its shape or size of the body, to change its position, tends to change its position, tends to accelerate any body, force is applied. So we can define theoretically. Mathematically, force can be defined as the product of mass and acceleration. M stands for mass here, A stands for acceleration, M into A. This is called the basic definition of force. Okay. However, this definition is derived by Newton's second law of momentum. When we talk about SI unit, so SI unit of force is Newton. We say Newton. Newton is a SI unit, so Newton can be elaborated as 1 kilogram meter per second square. 1 Newton equal 1 kilogram meter per second square. When we write CGS unit of it, centimeter gram system, centimeter gram second system, the CGS unit of force is dyne, D-Y-N-E, dyne, and 1 dyne can be written as 1 gram centimeter per second square. So we can compare Newton and dyne. So 1 Newton can be equal 10 to the power 5 dyne. So this is the relation between the Newton and dyne, and this is the SI and CGS unit of force. Force can be classified as contact and non-contact forces. For example, friction force is a contact force, gravitational force is a non-contact force, electrostatic force is a non-contact force. This is the basic difference. We can also classify force as balanced and unbalanced forces. Balanced forces is that, for example, there is a particular point, a body, there are some forces acting on it, F1, F2 and F3. When we say F1 plus F2 plus F3 equals 0, means all acting forces equal to 0, it means these are called balanced forces. If does not, F1 plus F2 plus F3 not equal to 0, so this will be called unbalanced forces. So this is the basic difference, balanced and unbalanced forces. Now we take another term, that is inertia. Let me write it for you. Now we take another term, inertia. Inertia is what? So inertia is the inherent property of any material by virtue of it resists to change its state of rest or state of motion, whatever it is. Okay, means if we don't apply any external force on a body, for example, body is lying on a surface, it will lie on that surface until or unless an external force applied on it. However, there is a force acting on it, like normal reaction force acting in upward direction and weight is acting downward direction, but there is a condition of balanced forces. There is no external force on it. So that's why body will not change its state. Body will not change its state. If it is at rest, it will remain at rest. If it is in uniform motion, it will remain in uniform motion until or unless external force applied on that. If we apply external force, okay, however, there is some friction force also there. If external force is greater than the friction force, the body starts moving. So the observation is that inertia is a property. Inertia defined as the inability of a body to change its state without applying a force. Okay, so this is called inertia. Now we talk about momentum. Momentum. What is momentum? Momentum, however, defined as the product of mass and velocity m into v, depends upon two factor mass and velocity. But theoretically it has a significance. It defines as the amount of motion. Okay, how much motion a body has, कितना motion है body के पास, we will define by this term momentum, and it is defined as the product of mass and velocity. If mass changes, so definitely momentum changes. If velocity changes, definitely momentum may change. Okay, so there are also some relation also here. For example, mass is constant. Okay, so momentum directly proportional to velocity. We will apply mass is constant, we will apply velocity, the momentum will be greater. In second case, for example, velocity is constant, so momentum is directly proportional to mass. Okay, greater mass has greater momentum if velocity is constant. Now we take another third case. For example, momentum is constant, so mass is inversely proportional to velocity. So this is the basic term momentum. If you talk about SI unit, yes, definitely it's a unit, it's a dimensional quantity. So SI unit is kilogram meter per second. There is also CGS unit, gram centimeter per second we can write. Okay, this is the momentum. Now we move to the next concept, which is very important, Newton's laws of motion. In your first chapter you have also studied about the Newton's equation of motion. These are laws. Newton's laws. Newton's laws of motion basically. There are three laws. Number one, law of inertia. Okay, we have studied inertia. Inertia क्या है? Inability of a body to change its state without applying force. So that's why law of inertia says every body continues in its position until or unless an external force applied on that. If body is in uniform motion, it will remain in uniform motion. If body is at rest, it will remain at rest. This is called law of inertia. There are also examples. In order to remove some dust particle, we beat a carpet. Okay, just an example of law of inertia. We are we are traveling in a bus starts, suddenly we get a jerk in opposite direction of the motion. This is the example of law of inertia. Okay, there are many examples in nature. Find out and search and write down in your notebooks. Now we take another law of momentum. Yes, you know very well what is momentum. Momentum is the product of mass and velocity. Okay, for example, any body of mass m moving with velocity u, now body attains velocity v after time t. Mass, for example, is constant. Mass is same here. Okay, u to v, but there is a change in velocity. So at this point, momentum, here is velocity u, here is velocity v. So obviously there is a change in momentum. Momentum is p1. At this point, for example, this is a point A, this is the point B, and at point B there is a momentum P2. So we measure this change P1 to P2. How it is happening? क्यों हुआ ऐसा? Why it is changed? So we measure this change, the rate of change in momentum. Obviously, is directly proportional to applied force, because without applying any force, body doesn't change its position. Okay, doesn't change its velocity. If there is a change in velocity, definitely there is a force applied on it. So that's why we say force is directly proportional to rate of change in momentum, means delta P upon delta T. Delta stands for change here. Okay, this is called law of momentum. By using this concept, we can also write F equal ma. Okay, we can write by using this concept. Okay, I will tell you in another video. Now we talk about another law, action reaction law. Third law is that action reaction law. What does it say? क्या कहता है action reaction? For example, if there is a force on any body, there is a normal traction force acting on upward, so definitely there is a downward force. Okay, if there is a force, definitely there will be another force, equal and oppositely acting. Means every action has an equal and opposite reaction. The law says action reaction law. Okay, now in this condition the body has the property R equal minus mg. Net force on the body, if we say, will equal 0. This is the balanced force condition. Okay, so there is a condition of action and reaction. For example, if we take example of two bodies, for example M1 and M2, okay, and they are lying on a table. If M1 is applying some force on 2, like F21, and 2 will apply some force on 1, means F12, so definitely F12 will be equal and opposite F21. This is the action and reaction law. So there are 3 laws of Newton. Okay, I hope it is clear to you. In next video we will move further. Okay, thanks for watching. Thank you very much.